Today's topic is a quite important topic in microeconomics. It is the topic of duality in consumer equilibrium, that is a very renowned topic of the consumer behavior portion of microeconomics. Now, for getting into the consumer equilibrium or duality in the consumer equilibrium, we have to understand the basic theory of the duality in consumer equilibrium. Now, what is duality? Duality is basically being a rational consumer. I would always try to maximize my utility within my limited income, and at the same time, I will try to minimize the cost for getting the same amount of utility. Okay, so these are the two things or two aspects that I will try to cover at the same point of time. One is to maximize my utility within my income, and another one is to minimize my cost within and minimize my cost keeping my utility same or constant. So these two perceptions are called duality in consumer equilibrium. One is keeping your utility same and minimizing the cost, and second one is getting high utility with limited income or with the income that you have. Now, duality in consumer equilibrium is a concept that relates to the relationship between utility maximization approach and the expenditure minimization approach in analyzing consumer behavior. As I have told you that it is basically the utility minimization approach and cost utility maximization approach and cost minimization approach. Okay, I was just checking the size of the brush. Yeah, now it looks okay. Now, at first we will go with the utility maximization approach, then we will go with the cost minimization approach. Now, what is utility maximization approach? It is basically try to maximize your utility within the limited income or limited budget that you have. So consumer always tries or always aims to maximize their utility within a limited income or within a given budget constant that they have. Now, if we have a function that is utility function, which is a function of x1 and x2, and that function is equal to x1 into x2, and we have a subject to budget constant that is m equals to p1 into x1 plus p2 into x2. Now, for getting the values of x1 and x2, and getting the indirect utility function, what we can do? We have to do the partial derivative of after forming the Lagrangian of this utility function. So we will at first form the Lagrangian of this function, and the Lagrangian will be x1 into x2 plus lambda into m minus p on x1 into p to x2. So we will do the partial derivative of this function with respect to x1, with respect to x2, and with respect to lambda. Now, at first, if we do the partial derivative of this function with respect to x1, then that will be obviously x2 minus lambda p1. Similarly, we have done the partial derivative of this function with respect to x2, that will be x1 minus lambda p2, and we have done the partial derivative of this function with respect to lambda, that will be m minus p on x1 minus p to x2 equals to 0. So these are the first order conditions, that all of these x2 minus lambda p on x1 minus lambda p2, m minus p on x1 minus p to x2, all of these are equals to 0. By comparing the values of lambda in both of the scenarios, we have obtained this x2 by p1 equals to x1 by p2. By cross multiplying, we are obtaining x2 into p2 equals to x1 by p1. We are going to substitute this value of x2 p2 equals to x1 p1 in this budget constraint, or in this Lagrangian partial derivative with respect to lambda. Now, after substituting this, we are getting that m minus p on x1 minus p on x1, because we have substituted the value of p to x2 as p on x1 in this equation. So m equals to 2p on x1. we have gotten the value of x1 from here, that is m by 2 p1. In the same fashion, if you put the value of x1 p1 equals to x2 p2 in this equation, if you put the value of x1 p1 equals to x2 p2 in this portion, and if you determine the value of x2, then it will be x2 equals to m by 2 p2 in the same way. Now, so we have obtained the value of x1 and x2. Now x1 is basically function of m, that is income, and p1, that is the price of x1, and x2 is also a function of m, that is the income, and p2, that is the price of x2. So x1 is the function of income and price, and x2 is also the function of income and price. These are called the Marshallian demand function. Very important topic. Marshallian demand function is the function where the commodity is represented by income of the consumer and the price of that commodity. So these x1 and x2 are the Marshallian demand function, and if we go through with this Marshallian demand function, and if we put this value of x1 and x2 in the utility function, what was the utility function? The utility function was the utility function was u equals to, as you can remember, you can back forward the video and you can watch it from there also. Utility function equals to x1 into x2. So putting the value of x1 and x2 in the from the obtained values, we are getting the value of utility function equals to m square by 4 p1 into p2. This is not b square, this is supposed to be m square, and this is also supposed to be m and m. Now this is called indirect utility function. Now I am going to tell you about the indirect utility function's definition. What is the indirect utility function? Indirect utility function is the utility function where utility is represented by, or utility is a function of, price of the commodities and the income of the consumer. As you can see here, the function, not the utility function here, is represented by m square, that is income, and p1 into p2, that is obviously price of the commodities. So where the utility function is the function of income of the consumer and the price of the commodities, then it is called indirect utility function. Now we are going to take forward the conversation towards the expenditure minimization approach. Till now we are studying about the utility maximization approach, where we actually have maximized our utility by determining the indirect utility function. Now we will go to the expenditure minimization approach. Now in the expenditure minimization approach, our goal is to attain the same level of utility, or our goal is to reach the same level of utility, but we also want to minimize our cost or our expenditure on the goods and services. Now what is our problem here? Our problem is to minimize the cost. The cost is given as p1 into x1 plus p2 into x2. p1 is the price of x1 and p2 is the price of x2. x1 is the amount of good one consumed and x2 is the amount of good to consumed. What is our subject to constant? Our constant is basically here is to keep the utility same. So our constant is basically u star is equal to function of x1 and x2 equals to x1 into x2. This is our subject to constant. Now we will also try to form the Lagrangian here in this case also, just like the previous case. We have also formed the Lagrangian here, that is p1 into x1 plus p2 into x2 plus lambda into u star minus x1 into x2. We have just taken this into the left hand side, so it becomes, here most of the students have a confusion in these cases, so let me clarify it a bit. Although this is very easy, u star is basically u star minus x1 into x2 is nothing but 0, so we are multiplying it with the lambda, so we are getting 0 here. So L just is remaining p1 into x1 plus p2 into x2, which was actually the expenditure function. So now we have been successful to set the Lagrangian. Now we will do the partial derivatives of this LD with respect to x1, then with respect to x2, and then with respect to lambda, just as it was the case in the before. Now you can see that by comparing the values of the lambda from both of these derivatives by x1 and x2, if we compare the values of lambda, then we are getting this p1 by x2 equals to p2 by x1. Obviously it is not difficult to calculate the value of x2 from here. The value of x2 will be p1 into x1 by p2. If we substitute that value of x2 into this form, now in the third equation was u star equals to u star minus x1 into x2 equals to 0. So u star is obviously equals to x1 into x2, and x1 is becoming u star by x2 by just taking the x2 in the left hand side. Now if we put the value of x2, that is the value of x2, if we substitute this value of x2 here in the place of this x2, then we have obtained x1 equals to u star by p1 into x1 by p2. Now by doing a little calculation, we have obtained the value of x1 square, that is just taking this x1 into this left hand side, we have obtained x1 square, and by square rooting both the sides we have obtained the value of x1, that is root over u star into p2 by p1. Now if we take the root over out, then it will be obviously u star into p2 by p1 to the power 1 by 2 as it is written here. Now this is the value of x1. Now here it is very important to understand that this is also an important terminology in microeconomics. Here x1 is a function of, very important, this topic is, here x1 is a function of utility obviously and the price of the commodities. Okay, so where x1 is a function of utility and price, this is called Hicksian demand function. And if x1 is a function of income and price, then this is called Marshallian demand function. I hope this concept will be very clear to all of you after this video, where x1 is a function of income, that is M, and price, then that is Marshallian demand function. x1 is a function of utility and price, then this is Hicksian demand function. Hicksian demand function. Similarly x2, if x2 is the function of income and price, then that is Hicksian demand function, and if x2 is the function of utility and price, then that is Hicksian demand function. So here we have obtained the Hicksian demand functions of x1 and x2, and these are the values of the Hicksian demand functions. As you can see, this is the value of Hicksian demand functions.